What is a mole? Mole is originally coined by German chemist Friedrich Wilhelm Ostwald. The amount of substance that contains as many elementary entities, for example, is atoms, molecules, ions, and other particles as there are atoms in exactly 12 grams of carbon-12. 1 mole is approximately equal to 6.02 times 10 to the 23rd particles. The value of mole is also known as Avogadro's number. Who is Amadeo Avogadro? Born in 1776 to a noble family in Turin, Italy, Amadeo works included experiment on gases, notable of which is the Avogadro's law. According to this principle, equal volume of gases at the same temperature and pressure contain the same number of molecules. Atomic mass. Why carbon is the basis for the definition of a mole? What is in the carbon? Carbon, specifically the carbon-12 isotope, is the basis of atomic masses of all elements. Atomic masses, although relative, are expressed in atomic mass units. Thus, on this scale, carbon has an atomic mass of 12 AMU. An atom with a mass half of that carbon-12 has a mass of 6. And atom with twice the mass of carbon-12 has a mass of 24 AMU. Following this basis, the mass of a hydrogen atom is 1 AMU. For oxygen, 16 AMU. For sodium atom, 23 AMU, and so on. Atomic mass is the mass of one atom of one element and is usually expressed in atomic mass units. Molar mass. Molar mass is the mass of one mole of an element or a compound, which is usually expressed in grams per mole, or in symbol G over mole. For an element, its molar mass is numerically equal to its atomic mass. So to illustrate, the mass of one atom of silver is 108 AMU. The mass of 1 mole of silver is 108 grams. And the molar mass of silver is 108 grams per mole. Is it possible to express the mass of a single atom in grams? Answer is, in the laboratory, it is not possible to weigh a single atom. However, with the relationships that we have established earlier, we can find the mass of an atom in grams. So in our previous example, the molar mass of silver is 108 grams per mole, and the Avogadro's number, according to Avogadro's law, each mole has 6.02 times 10 to the 23rd atoms. Thus, the mass of 1 gram of atom is equal to 108 grams per mole times 1 mole divided by 6.02 times 10 to the 23rd atom. So, cancel the mole symbol, then divide the 108 by 6.02 times 10 to the 23rd atoms. And you will get the answer 1.79 times 10 raised to negative 22 grams per atom. So the mass of 1 gram of atom is 1.79 times 10 to the negative 22 grams per atom. Molecular mass and formula mass. Molecular mass is the mass of 1 mole of covalent compound. Since molecules are composed of atoms' molecular mass is the sum of the atomic masses of its constituent atoms. Water is a covalent compound of 2 atoms of hydrogen and 1 atom of oxygen. So let's compute the molecular mass of water. Since water has a chemical formula of H2O, therefore it has 2 hydrogen. And the atomic mass of 1 hydrogen atom is 1.008 AMU per atom. So 2 hydrogen atoms times 1.008 AMU per atom, that would be 2.016 AMU. Then for oxygen has an atomic mass units of 16, and water have 1 atoms of oxygen, therefore 1 atom of oxygen times 16.00 atomic mass unit. Then add molecular mass of H2O is equals to 2.016 AMU plus 16.00 AMU. The answer is 18.016 AMU. Molecular mass. Therefore, the molecular mass of water is 18.016 AMU, which can be rounded off to 18.02. Note that since atomic masses are in atomic mass units, the resulting molecular mass is also in atomic units. Formula mass. Ionic compounds such as sodium chloride are not molecular. They exist as ions. Hence, for these kinds of compounds, the term formula mass is more appropriate to use than the molecular mass. Calculation of formula mass is the same as that of molecular mass. Thus, for sodium chloride, its formula mass can be computed as 1 sodium is equal to 1 atom times 22.99 atomic mass unit per atom is equals to 22.99 atomic mass units. 1 chlorine is to 1 atom of chlorine is 35.45 atomic mass unit per atom. Therefore, the formula mass of sodium chloride is 58.44 atomic mass units. Okay, so calculate the molar mass of water. Molecular mass of water is 2.016 atomic mass units plus 16.00 atomic mass units. So that would be 18.016. Mass of 1 gram of atom is equals to 18.02 gram per mole times 1 mole of mass of 1 silver atom is equals to 18.02 gram per mole times 1 mole per 6.02 times 10 to the 23rd atoms. So, cross out the mole, then divide 18.02 by 6.02 times 10 to the 23rd, that would be 2.99 times 10 to the negative 23rd gram per molecule. Mole concept. Thus, it can now be established that a covalent compound's molar mass in grams per molecule divided by Avogadro's number gives the molecular mass of the compounds in grams per molecule. So, molar mass in unit, it would be gram per mole divided by Avogadro's number, which is in molecules per mole, is equals to molecular mass. Unit is gram per molecule. So if the molecular mass is multiplied by Avogadro's number, you will get in reverse the molar mass. Likewise, in ionic compounds where the formula mass is more appropriate to use, the same relationships hold. Molar mass divided by Avogadro's number, or formula units per mole, would result into formula mass. When formula mass is multiplied by Avogadro's number, you will get the molar mass of the compound. Mass to mole conversion. The mole concept is the cornerstone of quantitative chemistry. Conversion from mass to mole is vice versa and can be made possible by following the simple dimensional analysis. Number of moles multiplied by molar mass is mass. When mass is divided by molar mass, you will get the number of moles. Example: silicon is an element used in the semiconductor industry. How many grams of silicon corresponds to 10 mole of silicon? Solution: based on the periodic table, the molar mass of silicon can be taken as 28.1 gram per mole. Following the scheme, 10 moles times the molar mass of silicon, which is 28.1 gram per mole, you will get a product of 281 grams. So the answer is 10 moles of silicons have a mass of 281 grams. Next sample. Acrylonitrile. Acrylonitrile is used to make acrylic plastics. How many moles of acrylonitrile are there in 1 kilogram of compound? Solution: the molar mass of acrylonitrile is 53 gram per mole. So moles of acrylonitrile is equals to 1 kilogram per 53.0 gram per mole multiplied by 1000 gram per 1 kilogram. Then you will get answer 18.9 mole. Answer: 1 kilogram of acrylonitrile is equivalent to 18.9 moles. Percentage composition of a compound. One way of describing a compound is by giving the amount of constituent elements present in a given amount of a compound. This can be conveniently expressed as percentage. For example, the mass percentage of each element in the compound. Suppose that A is an element in the compound. The percentage mass of A, or percent mass A, corresponds to the parts of A per 100 parts of the total mass of the compound. If you're going to put that in equation, percent mass A is equals to mass of A present in 1 mole of compound divided by mass of 1 mole of compound times 100%. During the computation, the masses may be expressed in units of either atomic mass units or gram per moles. Recall that atoms' mass in atomic mass units is numerically the same as its element's molar mass in gram per mole. Example: what is the percentage composition of ammonia? The chemical formula of ammonia is NH3. Solution: 1 mole of NH3 contains 1 mole of nitrogen and 3 moles of hydrogen. Their masses can be computed as, for nitrogen, 1 mole times 14.0 gram per mole is equals to 14 grams. The mass of hydrogen equals to 3 moles times 1.01 gram per mole is equals to 3.03 grams. Add the two values. Therefore, the mass of ammonia is 17.03 grams. Computing the percentage composition or the percentage mass N, 14.0 grams divided by 17.03 grams times 100 is 82.2%. Link. Okay, so choose the background, then chart type, normal. Next, click enter data. Since we have two elements in our example, the number of slices is 2. Then the name first is nitrogen. And hydrogen. Okay, so in our example here, nitrogen is 82.2. So you're going to input that value in this 82.2. While for hydrogen, we have 17.8. 17.8. Next, after inputting the value, click the labels. In graph title, you are going to write ammonia. Then display. Okay, so the graphic representation of ammonia is like this. So this green part is the nitrogen and this orange part is hydrogen. Then you can download this graph. And there you have it, the graph of ammonia.